hydrogen engine, we need to understand how this hydrogen gas is formed and how it will be transported and how this hydrogen gas is used in the vehicle. So why specifically the hydrogen gas need to be used in the engines of all the vehicles and even in the manufacturing industries? To understand in detail, we need to understand what is hydrogen gas. So mainly the hydrogen, which stands for H2. It is the lightest and most abundant element in the universe. It, it is a colorless, odorless, and tasteless and non-toxic. And it is a highly flammable gas. Mostly, this hydrogen is found in water in form of H2O and called hydrocarbons and rarely in the pure form. It acts as a energy carrier, not a fuel source itself, storing and transporting the energy efficiently. The top benefits of the hydrogen gases will be uh, it will be the clean and renewable. So here the greenhouse. So for the greenhouse energies, here the green hydrogen is 100% renewable with the zero emission. Only by the product, it will be a form of the fuel cells, means the water vapor. And high energy density, so it is 3 times more energy per unit mass compared to the gasoline. And we are able to run the vehicle long range, and we can operate the drones and industrial powers as well with the help of this hydrogen gas. And it is the decarbonized, hard to reach the sectors, and where we are replacing all the fossil fuels like the petrol, diesel, other part of coal. Everything will be replaced by the hydrogen gas in the cement or the steel manufacturing industries, and even in the heavy duty trucks and vehicles, and the aviation and the marine transports. And mostly the energy storage for renewables will be the solar or wind energy. With help of that, we'll do the electrolysis and we'll generate the hydrogen gas. And as a back power source, um, with the help of the wind energy or the solar energy, we are able to generate the electricity. So next will be the clean transportation fuel instead of the fuel or the petrol, and for the batteries, even it will be support for the vehicles where we are able to fill this hydrogen gas within the limit of 3 to 5 minutes, and we are able to drive up to 600 kilometers. And moreover, it will be produced by the water vapor, and we can use this hydrogen gas in the multi sectors like industries like heating and processing, and moreover the home related the cooking and eating. And we have the backup grids will be available to make whenever the hydrogen gas is not available, we can use this power grids and portable devices. So we are able to port the hydrogen stored cylinders whenever we require. And the use of this hydrogen gas, it will be the economic growth will be increases towards the job creation in the manufacturing and infrastructure and R&D and green innovation. And it will stimulate this new market and investments. And coming to the grid stability, acts as the load balancer for the power grids and converts the surplus powers into the storable fuel. And next will be the part of a safe when handled properly, like it will be a non-toxic, it won't be harmful of the hydrogen, and it will be flammable, but it will be disappear rapidly whenever we need to use. And the handling the safely, we need to know some rules and regulations when we are understand about the gases, how we are able to store and how we are able to transfer it. So now we need to understand there are different types of hydrogen gases. Just we need to aware. The first part is the gray and hydrogen. So it is produced from the fossil fuels like the natural gas. So it emits carbon dioxide more in the gray hydrogen. And coming to the blue hydrogen, it is produced from the fossil fuel, but it is a capturing of the carbon and the storage of CCS to reduce the little bit emission of the CO2. So here CO2 is the carbon dioxide. So blue hydrogen is a better than the gray hydrogen. And next will be a part of a green hydrogen. So the green hydrogen will be produced from the solar or the wind or hydro energies. So here it will be the zero emission compared to the gray hydrogen and blue hydrogen. The green hydrogen, it will be a good part of hydrogen gas that can be produced with the help of the solar and wind and hydro energies. And next will be the turquoise hydrogen, where it will be produced by the pyrolysis of the methane. Like we used to the methane metal gas or the metal, like we are able to produce the solid carbon instead of CO2. So this is a little bit complicated. Like we are able to operate and produce the different types of hydrogens. And next will be the part of how this hydrogen is classified based on how it will be produced. So the different types, as we know, the green hydrogen, blue hydrogen, and the gray hydrogen. So coming to the green hydrogen, it will be electrolyzers using the renewable energy like the solar and wind. It will be the zero emission. And blue hydrogen, it will be the part of the steam method we use, and with the capturing of the carbon, and it will the low emission will be there. And the gray hydrogen, it will be a part of the steam method reforming SMR without carbon capturing. It will be the high emission of the CO2. And how the future of the sustainability transfer will be happen, like how this hydrogen gas will be produced. This hydrogen gas will be produced in different stages. So like initially it will be the part of the wind or the solar or the hydro or the nuclear that will be done with the stage of the electrolysis with help of water, and parallelly we need the air separation. So then we are doing this anomia synthesis, and then will be produces the hydrogen. And similarly from the natural gases like CH4 or the steam or steaming of the methane pyrolysis and the steaming of steam methane reforming, with the help of this we are able to produce the hydrogen gas. This can be used to be transferred in the form of cylinders, and that makes the produce the more and more hydrogen with the help of the sources from the energy, wind energies or the solar or a hydro or nuclear or some of the natural gases. So the future of hydrogen, it will be formed as through the wind or the solar or the water hydrogen. So mainly the renewable energies, it will be more, and next will be part of a natural gases and steam methane. It will be a part of one where we transfer, and thermocol and methane pyrolysis. So these are the stages where the hydrogen gas will be produced. And the more focus towards the hydrogen is the great energy, how that can be made towards the nature. It cannot create the more impact on the existing lifespans of the life activities. So renewable energy is the one which makes the more creativity of generating the hydrogen gas. And coming to the storage and infrastructure, there are different two stages. This is hydrogen that can be stored in the compressed gas tanks at 350 to 700 bar pressure, and the other method is the cryogenic liquid hydrogen storage. It is another method. It is required to cooling the hydrogen of minus 253 degrees centigrade. So there is a lack of refueling stations. Is a major barrier to adopt this. And mostly comparing of about two the storage methods, like we have the short type, the compressor gas, the most common, and the pressure it will be 350 to 700 bar. And the advantages, it is a common and proven technologies. Disadvantages, it is a heavy and requires the large tanks for storing this compressed gas. And the other one is the liquid hydrogen LH2. It is a part of cooling the hydrogen to minus 253 degrees centigrade. And the advantage is higher the energy density, but it is a complex cooling system is needed. That is the one disadvantage. And to understand about the hydrogen, how it is formed and how it will be stored, what are the methods we have. So just to understand why this hydrogen is making the implementation on the vehicle. So to understand that every vehicle needs a engine to run. So here the hydrogen engine, it will be a part of the water will be exhausted during the emission. So H2O. To understand in detail about how the engine works and how that will be implemented in the vehicles, we are going to in detail. So here, the main working principle of the engine is like we have a 4 cycles: the intake and the exhaust, compressor, and power. And this will be a part of the 4 cycles where the crank and cam will be involved to make the engine to start and run. So the piston is the one where it keeps the air or the mixing of the fuel or mixing of the diesel or mixing of the gases that will be observed by the piston towards the cylinder. So where every vehicle for the trucks, cars, trains and marines, and even in the aviations, ships and aerospace, everywhere needed this H2 gas. This cannot make harmful to the environmental. So that is a major scope. The green energy will be converted, making the nature better and supportive. Uh, it it cannot make the human life difficult coming to the future wise. So this is some advanced. So how these hydrogen gas will be implemented in the existing engines or the new engines, that we are going to understand in detail. Why this hydrogen engine? So hydrogen engine is a propulsion system that uses the hydrogen as a fuel, which either burns hydrogen in an internal combustion engine, we call as a H2ICE. It is similar to the gasoline or the diesel engines. The other part is the hydrogen fuel cells, FCEV. It is specific to generate the electricity and power to the electric motor. These are the 2 types of engine as of now that can be considered in the vehicles. The first part will be the hydrogen internal combustion engine, H2ICE. It works on the principle of a modified conventional engine, and here it will be the zero CO2 emission, but produces the NOx. And other is the fuel cell electric vehicle, FCEV. It converts the hydrogen into electricity via the fuel cell to power an electric motor. It is a zero emission and more efficient than ICEs. Means the compared to the above internal combustion engines, this fuel cell electric vehicle is better for the features of zero emission, and it will be less CO2 compared to the IC engines. And what are the types? As we know, H2IC is it burns the hydrogen instead of the gasoline and diesel, and it produces a low emission, mainly with the water vapor and some NOx. And it's suitable for heavy duty vehicles like trucks and buses. And the next will be the part of the hydrogen fuel cell engines, FCEV. It is used to a fuel cell to convert the hydrogen into electricity, power the electric motor, make it a zero emission, only water will be released, more efficient than H2ICE, ideal for passenger cars and long range transportation. So over the future look of this, both have the potential with FCEVs leads in the efficiency, and H2IC is a benefiting from existing engine technologies. And coming to the hydrogen ICs, work similar to the traditional gasoline engine, but instead of gasoline or the diesel, they burn hydrogen gas. And how this H2IC works? So here, coming to the hydrogen is stored in the hydrogen tanks, as we know that 350 to 700 bars, and the hydrogen is injected into the combustion chambers and mixes with the air and ignites and produces energy. The main emission is the water vapor, but it can produce a small amount of NOx due to the high temperature combustion. And how this principle works in first is the fuel injection system. So where the port fuel injection, we call as a PFI, hydrogen is injected into the intake manifold. As we know, in the engine, like the first cycle is where the intake, so where the fuel or the gas or the fuel or the air will be mixing is happened. that will be enter into the chamber. So next will be the direct injection. Hydrogen is injected directly into the cylinder for the better power and efficiency. And next will be the combustion process. This is the second cycle. Once the gas is entered, so then it will be mixed with the air and ignite the spark plug. So in the engines, so for the combustion of this hydrogen gas, it's required the spark plug we call, and it is similar to the gasoline engines, but this will be burning the hydrogen expand and pushes the piston down to generate the power. And unlike the gasoline, the hydrogen burns faster. It can lead to the higher efficiency, but also challenges like the pre-ignition and knocking. And next will be the exhausting emission. Once the combustion has happened, the power cycle is happened. Now the exhaust is the one that dust will be emitted. So here our hydrogen gas will be enter into the cylinder, it will generate the power, and it will be exhausted as no carbon emission because the hydrogen contains no carbon. And next will be the small amount of NOx is emitted because of the high temperature combustion. It can be minimized with the exhaust gas recirculation mechanism we call as a EGR. So this is an exhausting process. With the help of exhausting process, the mechanism of NOx can be reduced. And water vapor H2O is the main emission product. Here, the difference from the conventional ICE, no CO2 emission as hydrogen doesn't contain the carbon. The design and modification required for H2 ICE. Since hydrogen behaves differently from the gasoline or the diesel, several modifications are needed. So the first part is the fuel injection system. So as we discussed, it will be mixed with the air and it will be falling into the chamber. So once that is done, then it will be the ignition system will be activated. It will adjust the knocking system and the ignition will be happen and will power the spark, and the power will be generated continuously. And the existed thing is like the mixing of the air and fuel ratio. It is it should be maintained linearly with respect to the air. It will be a ratio of 34:1 for H2, and similarly for gasoline, 14.7:1 is the gasoline. This is the ratio air fuel mixing is happening still in the vehicles. And next will be the part of exhaust system. So when the ratio is mixed, then the exhaust system should be maintained as no CO2 emission, but there is a small and more X emission due to the high chamber, as we know. To avoid that, water should be injected with the help of NOx to formation during the exhaust thing like EGR. And next will be the cooling system. So hydrogen burns at the higher temperature, so advanced cooling system is needed. This is a very crucial and very important in the hydrogen gas engines. The specific to the cooling system is very essential and very important for making the engine to run smoothly. And what are the main key features of H2IC? So uses the existing IC technology, can develop from current gasoline or diesel engines, and zero COx emission. Only the water vapor is produced except for minor NOx, and high power density, similar power output as gasoline engines, and fast refueling. Hydrogen refueling takes only 3 to 5 minutes, unlike the battery EVs. No need for the rare metals, unlike the fuel cells which use expansive platinum catalyst. And hydrogen internal combustion engines, how it can be configured. So like we have the fuel supply system. So high pressure hydrogen injection replaces the traditional fuel injectors, and air intake system. It is the turbochargers or the superchargers that should be optimized during the combustion. And next will be the part of the ignition system, uses the spark plug like the gasoline engines. And combustion chambers, it will be modified for the hydrogen and high flammable thing. And exhaust system, it releases the water vapor and minimizes the NOx2 emission. And cooling system, it regulates the engine temperature due to the high combustion heat. And next will be the part of how this hydrogen internal combustion engine happen. The advantages here it will be the familiar technology, uses the existing technology, make it easier to adopt and faster refueling. It takes 3 to 5 minutes to refuel, unlike EV that takes hours to charge or discharge in the EV vehicles. And next will be the part of a lower cost than the fuel cells. No need for expansion of fuel cell stack, and uses the existing manufacturing infrastructure, can be built in current engines, plans with small minor modifications. And the challenges of H2 ICs, here it will be the lower efficiency, less efficiency than FC EVs, around 30 to 40% of the percent in a fuel cell. And NOx emission, although it doesn't produce the CO2, but it generates some nitrogen oxides. And the main challenge will be the storage, hydrogen storage. It requires the high pressure tanks, and that will increases the vehicle weight. Coming to the other part of engine in the vehicles, hydrogen fuel cell electric vehicles, we called as a FCEV. So here the FCEV uses the hydrogen fuel cells to generate electricity, which powers the electric motor. So here we can see, we are able to observe there are the hydrogen and the oxygen, and we have the proton and electron will be there. So the hydrogen is the one H2 fuel. It will be coming towards the catalyst, and H2 we have the recycling mechanism, and the cathode we have oxygen O2 from the air. It will be forming as water vapor when it is mixing. So this is a simple mechanism that is involved in the FCEVs to specifically for the fuel cell stack. So how this will be operated in the vehicle? So how it works? So hydrogen enters into the fuel cell from high pressure tanks. The fuel cell combines the hydrogen with oxygen from the air and produces the electricity and water vapor. It converts H2 plus O2, H2O, and due to the electrolysis, it produces the electricity, and that generates the electricity power. The electric motor will start rotates. And the advantages of FCEVs are zero emission, produces only the water as a byproduct, and higher efficiency, more efficiency than the hydrogen ICs, and it will be the part of 50 to 60% or the 30 to 40%, which will be the efficiency. And the quiet operation works like a EV, like it provides a smoother driving experience in the hydrogen. And the challenges of FCEVs, so expensive fuel cells uses a costly material like the platinum, and the hydrogen infrastructure, limited refueling stations compared to the gasoline or EV chargers as of now. Like going forward, if the hydrogen gas storages increases, there will be a scope of increasing the infrastructure of hydrogen, and the complex system requires the advanced technology for hydrogen storage and fuel cell management. These are the some challenges. And coming to the hydrogen tanks that stores, as we know, this is a compressed hydrogen. It will be a part of 350 to 700 bars, and fuel cell tank, it converts the hydrogen into the electricity via the electrochemical reaction. And the next will be a part of the electric motor, drives the vehicle using the electricity from the fuel cell. And the battery, like it stores the excess energy for acceleration and efficiency, that will be the option. And power electronics, it manages the electric flow between the fuel cells and battery and motor. And the next will be the part of cooling system. As we know, for hydrogen gas to cool, we need the cooling system. So whenever the generation of the power is happened from the hydrogen engines, so similar parallelly, we need the cooling mechanism. So that is a one important consideration is required. And the comparison of all this, like we have the future working principle, and uses the hydrogen IC and electric motor, battery for the efficiency in H2 IC, and FCEV uses the fuel cell to generate the electricity for the electric motor. So in both hydrogen ICs, burn hydrogen in a modified ICs like a gasoline engine, efficiency will be 40% lower than the fuel cells due to the heat loss, and FCEV 60% higher efficiency due to the direct chemical to electrical conversion. 35 to 40% it is a combustion losses emission, no CO2, but produces a small amount of NOx needs EGR after the treatment, and zero emission, only the water vapor. And conventional hydrogen, it will be the zero emission, only the water vapor. Refueling system, as we know, like H2IC, it will take only 3 to 5 minutes of filling. And FCEV, it is similar to the same. And in conventional hydrogen IC, also the same refilling of the hydrogen gas. It will be in both cases. It takes less time and complexity. It is a lower, similar to the conventional IC vehicle. And it will be the higher, requires a complex fuel cell system. And conventional hydrogen ICs, it will be the lower based on the existing IC. And maintenance, similar to the gasoline and diesel engine, where moving the parts and rest of thing, it will be the same. And it is a lower maintenance, fewer fast moving parts, and there is no need of changing the oil like gasoline or petrol kind of a diesel kind of vehicles. And FCV is the one where it will be operated with a battery and the hydrogen gases. So it is a better compared to the high to IC. And the next will be the part of a similar to the gasoline engines, a spark plug and injector and cooling system is required in the conventional hydrogen ICs. And next will be a part of the performance wise a high power output but slightly lower efficiency. And infrastructure requires hydrogen refueling stations more in H2 ICs. And cost wise, it is a lower initial cost. And FCEV is the higher initial cost compared to that. And conventional hydrogen, it will be the lower cost. Engine modification required. And ideal for the heavy trucks or construction equipment and locomotive and retrofitting existing fleets can be used. Passenger cars on long haul transportation and feeding application with infrastructure. And low efficiency and low emission and combustion losses will be there. So these are the main comparison. And real world applications relevant to the hydrogen ICs. The automotive industries can be used, and some of the cars like Toyota or the hydrogen ICs vehicles can be used, and Cummins X15H hydrogen trucks engines can be used, and JCB hydrogen construction equipments can be used. And some of the rail and marine applications, this can be used as the part of the vehicles, engines, and industrial and agriculture equipment. So hydrogen gas, it makes better when we start using on the industrial and agriculture equipments, and it will be the future development in the hydrogen IC. The advanced in hydrogen combustion, three-chamber ignition, water ignition system, and lean burn strategy. So this will help the efficient vehicle performance can be improved and improve the efficiency of the vehicle. And the hybrid hydrogen IC technology will combine the electric motor with H2IC for better fuel economy and the super capacitor energy recovery for efficiency booster. And green hydrogen production and infrastructure growth, electrolysis improvement to make a hydrogen cost competitive, and expansion of hydrogen refueling station. It will be increased slowly and drastically. And coming to the hydrogen gas is not freely available and must be extracted from hydrogen containers components, as we discussed earlier, like from the renewable sources and the natural sources. So then only the distribution of the hydrogen gas can be happened from the hydrogen storages. And as we discussed the storage mechanism, we have the comparison gases and liquefied hydrogens. So this can be used in all cases. The distribution mechanism is the one through the pipeline can be used, and the tube trailers where carrying of the higher pressure cylinders can be used for the transporting of these gases in the different mechanism. And it will be a part of a solid hydrogen trucks for longer distance. The solar system hydrogen gas generation will be the green energy. So it will be combined with the water, will do the electrolysis. Then that will be distributed to the cylinders. Next, the future of hydrogen ICs is a cost reduction, heavy duty focus, and regulatory support, and wider adoption. And the challenges of hydrogen vehicle: high production cost and limited infrastructure, and storage and transport issues will be there, and the energy efficiency and safety concerns. So these are the little bit challenges involved in the hydrogen vehicles. And the future focus is advancement in the storage and production infrastructure are key, making hydrogen vehicles are more practical and that will be widely adopted. So these are the main challenges involved in the hydrogen gas when we are need to use in the vehicles. Here are some key chemical equations to understand how this hydrogen gas will be formed. So hydrogen production via the electrolysis, when it combines the H2O, the H2 will be formed hydrogen and 2H2 and 2H2. So here the oxygen and hydrogen plays a major role when we do the electrolysis, means with the help of water. So hydrogen will be, but here the more water is required to generate the hydrogen gas or to produce the hydrogen gas from the water. So, and parallelly we require the electrolysis. So with the help of solar or the wind energies that can be performed. The next will be the part of hydrogen combustion. So here hydrogen burns with oxygen to produce the water and releases the energy. And hydrogen fuel cells reaction, FCEV. So with the help of the anode reaction, and we have the cathode reaction. So the hydrogen and oxygen reacted in the fuel cell to generate the electricity and water. So these are some chemical equation, how the hydrogen gas is extracted and how it can be produced from the different sources and how we are able to use in the vehicle engines. And this hydrogen, when it is combined with the different components or the metal lights, so that easy to adopt this hydrogen gas. So the same gas can used in different applications. Instead of batteries, we are able to use this hydrogen gas. But the impact of the hydrogen gas is the storage and the transportation. So these are the main important concerns. So based upon the requirement of the industrial purpose or the agriculture purpose or the vehicle purpose, so the usage of these hydrogen gases with respect to the cylinders, so this should be modified according to the new features or the new components that are integrating it. And hydrogen gases, how this can be used in the real world case studies, and how these ICs or comparison happen. So there are several major companies are actively developing and testing the H2 ICs vehicle. So there are some real world case studies it's happened toward the conventional and electric alternator. So we are going to understand in detail how it will be happen. So the first case study is the Toyota vehicles. They started the hydrogen powered engines, named as the Corolla and Hilux. The project is on the Toyota is testing the hydrogen IC. Is a modified Corolla and Hilux pickup truck. Here the cylinder of engine is the chamber. Here we say it is a 1.6 liter turbocharger. The 3 cylinders is used, and the performance is similar to the gasoline engine, but with nearer zero CO2 emission, because we are using the hydrogen gas. Hydrogen storage and NOx2 emission requires the advanced solution to prove hydrogen ICs as the practical alternative for the sport and utility vehicles. The second case study is the trucks, where it will be operated. The diesel engine manufacturer is developing the hydrogen powered truck engine. So it is the 15-liter hydrogen internal combustion engine is used, and the target vehicles is the heavy duty trucks and the long haul transport, and the construction equipments will be a part of the hydrogen gas engines. Here no battery weightage and faster refueling, as we know, and the current state it is in advanced testing. With we're able to expect in 2025 to 2030 this hydrogen gas engines can be formed. And the next will be the case of study of 3. So JCB hydrogen powered construction equipments. So we are able to use it in the mining and agriculture and and other industrial areas. So main intention is to build and test the hydrogen ICs where with respect to the load of the vehicle and how the load which it carries. So this makes that the using of the hydrogen engines will be is efficient and emission and performance, make it ideal for passengers and commercial transport. FCEV is the most efficient and conventional friendly, but it requires expensive infrastructure and fuel cells. And conventional hydrogen IC is the most cost efficient solution for high duty heavy duty vehicles, but has lower efficiency NOx emission. So